In this video, we're going to explore acid deposition. We often call it acid rain, but deposition is more encompassing because it explores all forms of precipitation, both wet and dry. So acid deposition is precipitation that carries nitrogen and sulfur compounds to ground level. And it can be caused by both natural phenomena and human actions. And when we say it's undergoing or caused by human actions, we say that's anthropogenic actions. So natural causes of acid deposition would be lightning. So lightning will heat the surrounding air and convert gaseous nitrogen to nitrogen oxides. Volcanoes release sulfur gases into the atmosphere during eruptions, and also rotting vegetation releases sulfur compounds as well. So human causes or anthropogenic causes would be burning fossil fuels containing sulfur or nitrogen compounds is the primary cause. And these would include power plants, industry, driving cars, and so on. And in the United States in 2007, 69% of sulfur emissions came from power plants. The emissions don't remain at the source, however, because prevailing winds can distribute the gases over large areas. So even though there might be the production of the sulfur and nitrogen compounds is local, it is still considered an international problem because of that dispersal of these compounds throughout large areas and over the course of the whole world. There are two different types of acid deposition. One of them is wet deposition and one is dry deposition. So wet deposition is the weather we typically think of as precipitation. So snow, rain, fog, sleet, and so on. Dry deposition would be acidic gases or solid particles. So they're released into the air and settle. So rainwater itself actually is not neutral. It has an acidic pH. It has a pH of around 5.6, and this is due to the mixing of carbon dioxide with water in the atmosphere to form carbonic acid in this reaction right here. So CO2 plus H2O makes H2CO3. Nitrogen monoxide is formed in two different ways. First of all, it's formed when lightning passes through air, and it creates nitrogen monoxide. And the second way is in internal combustion engines, but we have catalytic converters to reduce this production of nitrogen monoxide. And it's important that we do because it is a free radical. So in this reaction, nitrogen and oxygen react to form two nitrogen monoxides, and that is a free radical. Following this, nitrogen monoxide reacts with oxygen to create nitrogen dioxide. So we have 2NO plus oxygen making 2 nitrogen dioxide. And this also is a free radical, so it's going to continue reacting. So that nitrogen dioxide reacts with water to form nitric acid and nitrous acid. So HNO2 and HNO3. Those contribute to our acidic rain that we experience. So sulfur dioxide is formed when sulfur reacts with oxygen. So sulfur plus oxygen makes sulfur dioxide. And then sulfur dioxide in turn undergoes photochemical oxidation. So under light, catalyzed by soot and metal particles in the air, and that forms sulfur trioxide. Sulfur dioxide will then react with water vapor to form sulfurous acid, and then sulfur trioxide will also react with water vapor, but it will make sulfuric acid, or H2SO4. So the environmental impact of acid rain is vast. So acid can enter waterways directly or as runoff, and salmon can't survive below a pH of 5.5. Fish eggs won't be able to hatch. Aluminum will be leached from soil, and that will cause fish to produce mucus around their gills, and then they'll essentially suffocate. Calcium-containing compounds like shells of oysters and corals will start to dissolve, and biodiversity will be reduced, and acid-loving species will start to thrive. So not everything is going to die off with acid, but the natural organisms that would normally be there will be impacted. So sphagnum moss would be something that would grow a lot in acidic environments. And sometimes we think, oh, that lake looks really pristine and clean. Acid rain makes crystal clear water, but that's not a good thing. That actually tells us that there's no fish, no frogs, few insects, and lots of sphagnum moss. So not good to see a nice clear lake. So the effect of acid rain on buildings. Buildings and monuments that are made of limestone or marble will be damaged because they're made of calcium carbonate. So calcium carbonate reacting with sulfuric acid will make calcium sulfate, water, and carbon dioxide. So it'll actually eat away or erode the stone. So that's not so great. And also buildings made of iron, steel, and aluminum will also suffer corrosion, which will destroy the integrity of those buildings. So the effect on health, acid deposition can damage our airways and our mucous membranes, and people that have breathing problems, such like asthma, will be further impacted by acid deposition. So to reduce the impact of acid deposition, we can undergo two different methods. The first one is pre-combustion prevention. So in those cases, you are removing the sulfur before the fossil fuels are burned. And the second one is post-combustion method. So you could pass the sulfur and nitrogen oxides over a base to capture them. You could add lime to an area that's been damaged, so calcium hydroxide, to help restore back that area that's been damaged. And that's been done in great success in certain areas where we've perhaps mined. So in Sudbury, a lot of the surrounding area around the nickel mines was completely damaged. They thought that they had destroyed the ecosystem beyond repair. But students actually had done some research on acid rain and how to neutralize acids, and they thought, what if we added lime to the ground and spread it all over the place and see what happens? And sure enough, when they did so, plants were able to return and the ground was fertile again to grow plants and so on. So those would both be examples of post-combustion methods.